Hello and good day, pre-algebra, here with you on this Tuesday, January 5th, going back to PO24 and working more with function tables, but in more of a real-life context type of thing. And again, where this is heading, using these function tables in real-life situations, we're going to eventually be graphing these on the coordinate plane. And the function table is just one way to get ordered pairs for those graphs. So yesterday we went over creating function tables for a given rule. We did these 5 here together, and you had the Google quiz. And basically, just to recap this a little bit here, we'll go with the third one here. Your job was given a rule for the table, y equals 5x minus 8. Okay, we talked about inputs and outputs. The x variable being the input, it's what you are testing. The y variable is the output. It's what you get out of the equation. It is the result. Okay. And the cool thing about the inputs is that you get to pick your own. So we made an XY table, and we chose various values for x. I'll just go with 9 here. I don't remember if we did that one or not. But what we're saying is that what is the value of y when x is 9? So we're plugging 9 into the equation, multiplying it by 5. And then subtracting 8. And that rule, multiplying by 5 and subtracting 8, is what we're going to do every time we plug something in for x into the equation. So 5 times 9 is 45, minus 8 is 37. So when x is 9, y is 37. And we also talked about how what this gives us is an ordered pair that we could and will eventually plot on the coordinate plane, right? This ordered pair would be 9, 37, x value of 9, y value of 37. So then we pick another one. Let's do -1. We're going to use the same rule as we did with 9, that being multiply by 5 and then subtract 8. So 5 times -1 is a -5. -5 minus 8 is a -13. And that would be another ordered pair for this function table. Okay, so that's kind of where we were, where we've been. And today we're going to move forward into looking at some real-world application of this and different things that you can do. Okay, so you will have a Google quiz today. We're going to meet live tomorrow on Wednesday. So look for that Zoom link to meet live. And we're going to go over some of these together. I think we're going to get through 2 of them today, just kind of like an intro. And then tomorrow during our live lesson, tomorrow during our live lesson, we'll cover the rest. Okay, so here's the situation. After a week of timing yourself during your morning run, you discovered that you can run 4 miles per hour. Let H represent the number of hours you run, and D represent the distance you run. Well, first of all, what's up with H and D here? I thought we were talking about X and Y. Well, as it turns out, a variable is just something that represents a value. X and Y, when you're talking about graphing things, are the most common variables, but other variables can be used as well. In this case, we're using H because it's hours, number of hours you run, and D for distance. So it kind of helps us remember what these variables each represent. But when we talk about what is the input, as far as our coordinate plane is concerned, we're still talking about the X variable, that X value, what we get to plug in to test. And the output, we're still talking about the result, what we get out of it, or the Y variable. Okay, so one of these variables, H or D, is going to be the input, or X, and the other is going to be the output, or Y. But we're using H for hours and D for distance. So what is the input and what is the output? Okay, what are we going to be testing, and what are we going to be getting out of it? Well, a key word to look for here, and we've talked about this before, is the word per, right? That word per connects something to a variable. It means that you're multiplying. And what comes right before that is 4 miles, okay? 4 miles per hour. It might be easier to start with letter C, to write the equation, and then go back to what is our input, what is our output. We basically have 2 options here, right? We can say that 4 miles per hour, that word per means we're multiplying, equals the total distance that we run, or 4 times the total distance we run equals the number of hours we run. Which one of those kind of makes more sense or better represents what's going on here? This first one, right? 4 miles per hour we run will equal the total distance. We're not going to multiply the total distance by 4 to give us how far we went. Okay, that would be a different operation there. So 4 times h equals d. 4 miles per hour equals the distance. And so when we look at this, what's our input, what's our output? What are we going to be plugging in? What are we going to be testing? And what are we going to get out of it? Our input is h for hours. Our output is d for distance. If you're looking for a really great hint as far as to know which is the input, which is the output, take a look at letter D here, because I'm asking you to create a function table that will show how far you run in 3 hours, 8 hours, 12 hours, and 20 hours. Notice what I'm asking for. Hours, 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 right? I'm telling you how many hours you are running, and I want you to test each of those to get the total distance. I'm asking you to input the number of hours to get out the total distance that you run. Okay? So, our function table, XY table, or we're using H and D here. In 3 hours, if we go 4 miles per hour, we run for 3 hours, how far will we go? Well, we can look at our equation to help us here, right? If H is 3, 4 times 3 equals 12. If we go for 8 hours, if H is 8, 4 miles per hour for 8 hours, 4 times 8, 32. How about 12 hours? 4 times 12, 48 miles. And if we go for 20 hours, oh my goodness, 20 hours, 4 times 20, we get 80 miles. Okay, so we see the connection here in what we did on Monday, in that this function table, we are creating this table to help us predict, well, what if this happens? What if I run for this long? What if I go for this, right? Testing different times to get the total distance. Because let's say, and here's letter E, we're kind of going the other direction here now, letter E. Let's say that we want to run 62 miles, okay? Our end goal, our end location is 62 miles away, and we want to know how long it's going to take to get there, okay? So in this case, going from our 4H equals D equation that we came up with here, in this case, I'm giving you the output, right? We can also be given the output to solve for the input, okay? We're not testing, right? We are wanting to know. We know how far away our location is. We want to know how long it's going to take to get there. We're not testing anything. We're solving, essentially.
No need to come down. Thank you.
All right. So we can replace our distance with 62, right? Because this time I'm giving you the distance. I'm giving you miles, and we're going to solve. We have a one-step equation here. 4 times h equals 62. We're going to divide by 4. Opposite operations, get h by itself, and we get 15.5, or 15.5. So that tells us it'll take 15.5 miles, or sorry, 15.5 hours, 15.5 hours to run 62 miles, which makes some sense here, right? If we go back to our function table in letter D, where we tested 3 hours, 8 hours, 12 hours, and 20 hours, 15.5 is going to be somewhere between 12 and 20, and we know that in 15.5 hours, we can run 62 miles. Well, 62 is going to be somewhere between 48 and 80. So things fit, right? If we had solved this wrong, and we had gotten like maybe 20 instead of 62, we'd say, well, wait a minute now. 15.5 is between 12 and 20 for the hours, but 20 is between 12 and 32. That's a problem, right? That's a problem. It's not going to work out that way. So because we've got our values there, where placed where they are, we can feel confident that we've done this correctly. Okay? So going from the situation, looking at our variables, maybe writing the equation first, then identifying the input and output in order to make a function table, and then answer a question about the situation. That's kind of the 5-step process that we did for this. Okay, let's go over one more. Oh, capture. I hit hit the wrong button. I guess I wanted to make a memory. If this video lasts longer than 20 minutes, I apologize. I blame that. No, I don't want to save it. Clear ink. That's better. Okay. Next one here. You pick up a summer job. Mr. Schultz started working when he was 14. I've got a story about that. That pays a base salary of $500 and an additional $9 per hour worked. My job did not have that kind of payday, I will tell you that. But no, I was 14 years old. It was the spring break of my 8th grade year, and I was looking forward to sleeping in and doing all sorts of stuff that 14-year-old boys do when they don't have anything else going on, just relaxing and everything else. It was like 6:30 in the morning on Monday, and my dad comes in and he wakes me up and says, "Hey, I got your job. Let's go." Whew. And thus my working life started. 14 years old, spring break, 8th grade year. But anyway, so summer job, a base salary of $500 and an additional $9 per hour worked. Let H represent the number of hours you work and M represent the money you earn. So again here, we're not using X and Y. We're using H and M. H because we're talking about hours, and M because we're talking about money. If we wanted to replace H with X and M with Y, then we could, just to make it easier to graph. In fact, we probably would. But since we're not graphing it yet, using these variables are all right. It helps us keep track of what we are solving for, what they represent. So, an equation that relates the input to the output. Now, you can ask yourself here, okay, does the money that you earn depend on the hours you work? Or do the hours you work depend on the money you earn? Okay, another way to say that is like what affects the other, right? What directly affects the other? Well, if you want to make more money, you need to work more hours. If you work less hours, you'll make less money. There's a connection there going either way here, but if we want to get out, how much money am I going to make working this number of hours versus this number of hours versus this number of hours? We're going to be inputting the hours worked to get the money as the output. It kind of matches up in real life too, right? You put in the work, you get out the benefit. In this case, the work is the hours put in, the money is the benefit that you take out. Okay. Also, like I said, you can look at letter D here as kind of a hint. Create a function table that will show you how much you will earn after working an hour, and then I get to 8 hours a week, 5 days a week, 4 weeks a month. The point is, I'm asking you to test different lengths of time to see how much money you're going to make. So the input is going to be H. The output is going to be money. Another thing you can look for when deciding between input and output, your input, which remember on the coordinate plane is the x-axis, the output being the y-axis. The x-axis on a coordinate plane is usually going to be something that is measurable, such as time, right? Time moves at the same pace for everybody, okay? It may seem like math class goes really, really fast, okay, or really slow, right? But it's moving at the same pace for everybody. So time is going to be a very common x-axis value, or a very common input. Okay. All right. The equation, let's see, we've got a base salary of $500 and then $9 per hour. There we see that word per again. We talked about that in the last one, how that can be kind of used as a hint also. Per is attached to hour, which is our input. Okay, same kind of situation as the first one. So $9 per hour, that word per means we're multiplying. So $9 per hour, and then a base salary of $500. Well, a base salary is something that you get kind of no matter how many hours you work. You just get it just for showing up. Okay, you just get that for being hired. And if you want to make more money, you work more hours, but the $500 is kind of your base salary. That's going to represent our constant, because the number of hours we work doesn't affect that, right? It's just the base salary. So $9 per hour plus our base salary equals the amount of money that we're going to work. Or, sorry, the amount of money that we're going to earn. So that's the equation that we'll be using to solve our function table. So we have hours, and we have money earned. The first one, after working 1 hour. Okay, 1 hour. Well, that equation is going to look like this. 9 times 1 plus 500, right? We have the $9 for that 1 hour plus our base salary of $500 is going to equal 509. Okay, the next one says a day, which we're calling 8 hours. Typical length of work day. So if we work 8 hours, our equation is going to change only slightly in that instead of 1, we're going to plug in 8. So 9 times 8 is 72 plus 500, $572. But then it says a week, which is 5 days. Now, here's the thing. We don't want to go into our function table and put a 5 here for 5 days, because what unit is our H value in? Is it in days? No, it's in hours, right? So if we're working for 5 days and each day is 8 hours, this 5 days represents an H value of 40, right? We have to make sure that our units kind of stay consistent here. So our equation is going to become 9 times 40, which is 360, plus 500, $860. Okay. Now this last one, testing a month, which is 4 weeks. Well, we know that 1 week equals 40 hours. So 4 weeks, our H value that we're plugging in is 160. 40 times 4. Okay. I know that a week is 40 hours because that's what I got for that conversion there. So 1 week is 40 hours. We want 4 weeks, which is 160. So our equation, 9 times 160 plus 500. I tried to do this quick on my calculator and pushing all sorts of wrong buttons here, but it's $1,940. That's not a bad payday for a month, right? But it requires you that you work that number of hours. If we didn't work, if we only worked 1 hour, we're only at 509, okay? But you put in the more work, you get the more money out of it. 1,940. Then letter E. This is where I give you the input, right, to calculate the number of hours that you need to work. We're not testing anything. Let's say that you, how many hours do you need to work to earn enough to be able to deposit $750 into your savings account? Maybe you're saving up for a trip, or you're saving up for a phone, or you're saving up for some sort of pet or something. I don't know, but you are not testing something. You are solving for something. This is what I want. What do I need to do? Okay. So this time you're being given the output, your equation, 9H plus 500 is going to equal 750, right? Two-step equation to solve this time. Subtract 500 from both sides first. That gives us 9h equals 250. We're subtracting our base salary. And now we need to basically figure out how many hours do we need to work to make this happen. So 250 divided by 9 is 27.777777, repeating. Well, in the context of this, if we work 27 hours, we'll come up short. If we work 28 hours, okay, just kind of round up there, right? So that we get that full hour, get that full amount of money, it's okay to do that here. And how many work days is that? Well, if a work day is 8 hours, then 28 divided by 8 gives us 3.5. So you only need to work 3.5 days to make your $750. Now, that's including the base salary, right? So if the next week you wanted to make another $750, you would not be able to include that $500 because you already used that for your first $750, and it only happens once. Okay, so this is kind of what we're talking about here, this input-output stuff, and how we can take a situation, we can represent it as an equation, we can use it to predict future happenings, and then we can use it to solve for a specific situation. Okay, a specific situation. There is a Google quiz for you to finish, or for you to complete. We will finish this up tomorrow during our live lesson. So when you wake up, watch morning announcements at 8, and then be ready to head into Google Classroom to get the Zoom link, and we will pick it up from here. Until then, that's how you math. Do not forget to like and subscribe, and have a great day.